In this video, we're going to take a look at derivatives of polynomials. And let's start by just summarizing some of the key rules that we're going to be using. So first rule, if we have a function that is equal to c, c is just a constant, so any real number, then the derivative of that function, f prime of x, is equal to 0. Now we have a little bit of notation that allows us to summarize this rule a little bit faster. We could write derivative with respect to x of c is equal to 0. So this d by dx here just represents derivative with respect to x. Second rule allows us to deal with powers of x. So derivative with respect to x of something that looks like x to the n is equal to n times x to the n minus 1. And that's true whenever n is a positive integer. So just to make sure we understand what that's saying, if we took the derivative with respect to x of, say, x to the 10, to get the derivative, we bring the power, the 10, down in front, and we decrease the power on the x by 1. So it's going to become 10 x to the 9. So we could say the derivative of x to the 10 with respect to x is 10x to the 9. If we were to try, say, the derivative with respect to x of x, might be helpful to think of that x as really an x to the 1. And so our power rule here tells us that the derivative looks like 1 times x to the 0. And x to the 0 is just 1. So that gives us a derivative of 1. Third rule, that will be pretty important for us. If we want to take the derivative of a couple of different functions, then this rule tells us that to take the derivative, all we need to do is just take the derivative of one function at a time. So the derivative looks like f prime of x. Take the derivative of f first, then add on the derivative of g. So it'll be f prime of x plus g prime of x. So this is a very fancy way of writing the fact that we can take derivatives just one term at a time. Now, these three rules here can be checked using the limit definition of the derivative. But what we want to really practice is making sure that we can use the rules. So for our first real example here, let's find the derivative with respect to x of x to the 7 plus x cubed plus pi squared. This last rule that we wrote down here tells us that we can just take our derivatives one term at a time. So to take our derivative, we'll worry about the first term first, and we can go back over here to what's called the power rule. So maybe I'll write the name right beside that because we'll be coming back to this rule often. Power rule. So according to the power rule, our derivative looks like 7 times x to the 6. So the power just goes down in front and the power on the x decreases by 1. Then we can move over to our next term. Derivative of x cubed is going to be 3x squared. And then we'll need to add on the derivative of pi squared. Now, don't let this square here fool you. Pi squared is just a number. In other words, it is a constant, and we fall into the category of this first rule here. f of x is just any old real number, its derivative is going to be 0. So plus 0, and that gives us our answer. 7x to the 6 plus 3x squared is the derivative. Now there's just one more rule that we need to be able to take the derivative of any polynomial. We need to know how to take the derivative of something like a constant times a function. And to get the derivative of something that looks like this, we're just going to bring that constant out in front so nothing happens to the constant, and we take the derivative of our function. So derivative of c times a function is just c times the derivative of the function, and that's true as long as c is a real number. In other words, as long as c really is a constant. So let's try a little example here. Let's say we wanted to take the derivative with respect to x of 4x to the 7 minus 5x cubed. So first rule we're going to run into is this rule that we just discussed here, because we've got 4 times something that we know how to take the derivative of. So the derivative will be 4 times the derivative of x to the 7, which is 7x to the 6. And then we're going to go minus 5. You can really think of this as plus -5 if you want to think of it that way. So just keeping the constant out in front and then multiplying by the derivative of x cubed. So that's -5 times 3x squared. Okay, now if we simplify this a little bit, we've actually got 28x to the 6 minus 15x squared. And this might actually suggest a way of speeding up this calculation a little bit. If you look at what happened here, when we bring that 7 down in front from taking the derivative of the 4x to the 7, that 7 really just gets multiplied with a 4. So we could look at this and say, well, the derivative is going to be, coefficient will be 4 times 7, so 28, and the power will decrease by 1. So 28x to the 6. Over here, our derivative is going to look like minus 15x squared. Again, the coefficient is minus 15 because the 3 is coming down and multiplying with the -5. So with a little bit of practice, we will most likely start to jump fairly quickly to this step and not write out so many intermediate steps there. Okay, so let's try a more detailed example here. Let's find the slope of the tangent line to the function f of x, which looks like 9/2 x to the 4th minus 3x cubed plus root 2x minus root 2. And let's find the slope at the point 1, 3/2. Okay. So first step is to remember how to find the slope of the tangent line. Okay, so remember that slope of the tangent line is represented by the derivative. So this is a derivative problem. So here's the formula for the slope of the tangent line, and we're going to go through and use all our rules now to find this derivative. So let's start with our first term. The derivative is going to look like 9/2 times the derivative of x to the 4th, which will be 4x cubed. And then we've got minus 3 times the derivative of x cubed, which is 3x squared. Next term, we've got plus root 2 times the derivative of x Remember, x is really x to the 1, so the derivative is going to look like 1 times x to the 0. It's really helpful if you can just remember that the derivative of x is 1. I think you'll find that speeds up your calculation quite a bit. And for the next step here, derivative of a constant is 0. So that's just plus 0 there. So formula for the slope of the tangent line, if we simplify here, we've got 18x cubed minus 27x squared plus root 2. Now to finish off the problem, the question is actually asking for the slope at a specific point. So if we go back to this point here, it's the x value that we really need to plug into this derivative. So remember, this point is just giving the x and y coordinates in that order. So we need to pick out the fact that x is equal to 1 and actually plug that into our derivative to get the answer. So now that we've done the derivative, we can plug in x equal 1 and get 18 times 1 minus 27 times 1 plus root 2, or in other words, minus 9 plus root 2. And that's the final answer to that question. Now, one other topic that we need to discuss in this section is how to handle variables other than x, because we will often run into different variables as we go through our applications. So let's say we're asked to find the derivative with respect to, say, r of a function that looks like 6 pi r minus 2r cubed. So the fact that we have r in the denominator here just reminds us that we're doing a derivative with respect to r, meaning r is the variable that we're interested in this problem. So other than just changing the variable here, the rules are going to work the same way. This 6 pi out in front, that's a constant. So we're going to go 6 pi times the derivative of r. Derivative of r is 1. And then we can move over to our next term. We've got minus 2 times the derivative of r cubed, which is 3r squared. And that gives us our answer, 6 pi minus 6r squared. Now, we just need to practice doing this with slightly different notation. So sometimes we'll be given a function, not always going to be called f. So maybe we've got a function called v here. Let's say v is 4/3 pi r cubed. So you might recognize that as the volume of a sphere with radius r. We might write something like dv by dr. So that's just a way of saying derivative of the function v with respect to r. Okay, and again, our rules are going to work just as before. So this 4/3 pi out in front there, that's a constant. It's multiplied by the rest of our function. So we're going to keep it out in front and then multiply by the derivative of r cubed, which is 3r squared. And with a little bit of simplifying, we get our answer. So 4 pi r squared.